The other gas that is in the atmosphere that we don't talk about is water. And the water vapor and the molecules that are in the air, okay, are almost always part of evaporation, which is a little bit different. If I wanted to convert all water into gas, what I would do is put it on a pot and put it on a stove and heat it a lot. And it starts to boil. That's the conversion of liquid into gas. But if I took, let's say, a glass of water and I set it on that table and left it for 2 weeks, what would happen to the water inside the glass? It would go away, right? Will the water have ever boiled sitting just on that? I don't know, it feels kind of like that when the air conditioner is not running, but we actually don't get to boiling point. But inside the water, some molecules are moving faster than others, and some molecules can just have enough speed to jump out of the water and become a gas molecule. And over time, water will evaporate. The water that evaporates that isn't boiled, okay, is called vapor, and that's the definition. And the water vapor in the air is usually referred to, in terms of weather terms, humidity. Okay? The humidity comes from lots of places, mainly the ocean, but any body of water can evaporate water into the air. But soil also can. There's water under the ground, and so if sun hits the ground, water can come up through that. And one thing that you might not think about, but plants can give off lots of water. What happens is the roots of the plants are very deep and they are taking up water, take water up into the plant, and you have these broad leaves, and as the sun hits the leaf, water evaporates. And so you can be in the middle of, let's say, a jungle, and you don't see any sun, but it's very humid, and you're not next to water because all of those plants are giving off water vapor, and so it can be very, very humid. So water can get into the air from a lot of different places. Water that's added in the air by evaporation, okay, will eventually condense to remove that humidity, and so there's a balance. And so what happens is we have lots of water that is evaporated from the oceans, from the ground, from the soil and vegetation. So water comes up into the air, lots and lots of water. All right, and it will fill the air. Now, right now we have humidity. Can you see the water? Mm-mm. But every so often, if you take a look in the sky, you see water in the form of, what do we call that water? Clouds. What happens is any amount of air can hold some water. All right? But there's only so much air can hold. And so I can fill the air with water, I can fill the air with water, I can fill the air with water, and there is a point in time that I'm going to reach what's called the saturation point. As much as I can hold. And at that point, you can start to have the water condense into water droplets, even inside the air, and we form clouds. Okay? And we will condense. Now, if that cloud gets cooler, what happens to the air, the warmer it is, the more water it can hold. The cooler it is, the less water it can hold. So if you have an air that has some water in it, it's really, really warm, and suddenly you start to cool it, what happens is, the cooler it is, the less it can have. But I already have water there. So the colder and colder it is, it can get into a cloud, and the colder and colder it becomes, it can fall into rain. And so water comes up, creates clouds, and the rains come down, and the floods go up, right? And what happens is, as the rain hits the ground, it can be trapped up here in snow for a little bit, but then it might melt. If the rain hits here, it's going to start running off, and it creates little tiny rivulets, and those create to make streams, and the streams create to make rivers, and everything starts to run down. And it can run on top, on the surface, and sometimes it can hit a place where it kind of gets stopped, like a lake. but eventually it will run down. Another way that it can run down is inside the dirt and it runs down, but it always runs downhill. And eventually all water comes back to the ocean. And so the evaporation, the rain, the runoff, and back to the ocean is called the water cycle, and that's an important part of weather. The hydrolytic cycle also. Clouds. Clouds form simply when air contains water or vapor is cooled past the saturation point. Okay? And what happens is it's not gas anymore, it becomes liquid again. Now, that means I've got liquid sitting in the air. Well, why in the world does the liquid not fall? Doesn't water fall? It's either not cold enough, okay, and that's really, it has to be really cold. Because what you do is you make really tiny little drops. And they do fall, okay? They're constantly falling because the gravity is pulling on them. But what else is up there? Wind. And so if the drops are small enough, they fall, but the wind blows them back up, and they fall, and the wind blows them back up, and it falls, and you have a cloud that persists. Okay? Now, if the cloud's high enough, the little water can actually freeze into ice crystals. Could be a snowflake that's up there. So your clouds can be liquid water or it can be solid water, depending upon what temperature it is. Okay? And it can float around. Does every cloud rain? Nope. Cloud has the potential to rain, but cloud doesn't have to rain. You can actually go through a whole day and see clouds in the sky and not have one lick of rain. And actually, you can have clouds in the sky one part of the day, and then all of a sudden, no clouds, and it's never rained. Well, what happened? Here the air has water in it, and here the air is cold enough to have little drops of water. But this air could move over into some place that is a little bit warmer. What happens is, if it's warmer, the water can then evaporate back into a gas, and the cloud can dissipate and go away because that air got a little bit warmer. That's one possibility. Now, this cloud on this side could move in a different direction. And if this cloud moves in a direction where the air is colder, what can happen is the drops get bigger, and the drops get bigger, and the drops get bigger, and eventually the drops will get big enough to not just fall and be blown back up, but they will fall and hit the ground, and then you have precipitation. Okay? Now, those drops can be all sorts of things. If it's really high and really cold, the water drops and it can drop as snow way high. And then all of a sudden, as it goes lower and lower and lower, it gets warmer and warmer and warmer. What happens to that snow? It can convert right back to raindrops. Yes?
So
what is freezing rain? Freezing rain is rain that has fallen and it gets into a very quick or very large difference in temperature, and it will freeze so fast it freezes into a solid chunk rather than slowly building crystals. Okay? And so you can have that possibility. And so you could be in the middle of summer and you can see clouds and you can know that it's raining, but what you may not have known was when it started, it was snow. But by the time it hit you, it was rain. And so it just depends upon what layers it falls through and what temperatures it falls through. There are three main ways in which clouds are formed. And here is the big change in what you think about, okay? You told me that when you go on top of the mountain, it's cooler, right? That makes sense to us. The air is cooler not because it's higher, okay? The air is cooler because the air expands. If the air can expand or any gas expands, it becomes cold. there is a practical thing that you can feel where gas becomes cold. Has anybody ever had a can of compressed gas to like blow and clean stuff? Okay, inside the can, all the gas is compressed, pressed down. You hit the nozzle and the gas spreads out. Okay, if you hold that can, it gets cold. The principle is, it doesn't matter what gas it is, if it goes from compressed to spread out, it gets cool. Okay, that is the big thing about how clouds form. I have to expand and cool. Okay, the other two things, warm air holds a lot of water, cold air can't hold a lot of water. And so there are three ways in which air is forced higher, which then expands, cools, and potentially can create a cloud. One, a mountain. If air is coming towards a mountain, can't go through the mountain. The air gets pushed up. Getting pushed up expands it, cools it, and usually warm air has water. That's where clouds can form. If this is called topographical, but really the land pushes the air up at a mountain. It's kind of interesting. On mountain ranges where you have air that comes out like this, it is an example is in Southern California. I lived in San Diego. And so you've got the ocean. The ocean has a lot of water that is evaporated, and it's usually warm around San Diego. The air comes from the ocean to the land, and there's a very high mountain range that is relatively close. And you see clouds formed as the air gets forced up the mountain. On this side of the slope, lush forests. Up here, they have lots of ski resorts. So you can go surfing in the morning and go skiing in the evening because they're close enough to do that. And it gets so high that all the water falls on this side of the mountain. After it gets up and over, it's dry air. It falls on this side. This side of California is Nevada, New Mexico area, which you think of as deserts. And so on the other side of the mountain are the sand dunes where they could film something like Return of the Jedi and Star Wars, where there was all desert. It's because all of the air was forced so high, all the water fell on this side is dry. Okay? Another way in which air can be moved up is when cold air masses and warm air masses collide. Warm air tends to go up, just like a hot air balloon. Cold air falls down. When you collide, one of these gets pushed up, the warm air gets pushed up, and when it gets pushed up, it expands. We have clouds that are formed. The last is when you have lots and lots of sun, you heat up the air. The heated air can just rise like a hot air balloon, and as it rises, expands and cools. And so just a lot of sun heating air, making it go higher, expanding and cooling, can cause a cloud. And so if it hits a mountain, it gets pushed up and expands, or when cold air hits warm air and pushes the warm air, it expands and cools, or if the sun just heats it and it rises, expands and cools, are ways in which clouds can form. These are the three ways. Okay? A cloud doesn't have to completely rain out. A part of it can rain out. Okay? And it's when the water droplets get larger and larger and larger, they start sticking together and become heavy enough for it to fall. If it is cold enough, the water can freeze slowly and create crystals to create snowflakes. If it is very violently or very quickly cooled, it creates little tiny pellets called sleet or frozen rain. Okay? Or if there is, like in summer, the thunderstorms that are violent and large amounts of wind, what happens is the water can freeze and fall down, but because the air is so violent, it gets pushed back up. And it goes through the water. And it picks up more water and falls down and freezes, and it can continue that cycle to where the little tiny one gets more water and more water and more water and more water, and you get eventually hail. Something that you don't want to be out in the middle of, even if you're in your car. Okay, there are lots of times that hail has come through this area, and everybody gets a check for their car because it looks like someone drove your car through a driving range of golf balls. Okay, not really great. A couple of videos about how raindrops can actually form, which is kind of what you might not think about, but actually forming raindrops in the air by themselves, just a drop of water, is actually pretty difficult. And so it takes a relatively very cold situation in terms of the atmosphere, and if there is something for the water to start on, it tends to make the water drops easier to make. And so let's take a couple looks at a few videos that talk about that nature. So if you looked at that, the water doesn't tend to form on its own, but little particles of dust or pollen that are in the air are places for water to start. And you make a tiny little drop. Now, what is tiny? It said millions of those drops needed to form to get one little tiny 2-millimeter drop of rain. And so they are so small that you may not even be able to see them directly with your eye, but you see the cloud of all of them that are floating in the air. So dust particles and pollen can create spaces for rain to start. Now, my wife suffers from allergies, and I know a lot of people who live in this area suffer from allergies. A couple years ago, they gave a top 10 list of the cities for allergies in terms of pollen. Number 2 on the list was Knoxville. Number 3 on the list was Chattanooga, so I guess Cleveland's 2.5 on the list. We're right between, with lots of particles of pollen. We tend to get, so if there is no dust or clouds, what has to happen is it's got to get so cold that you create little particles of ice, and then the water can collect on that. Now, there was an idea that, okay, if you've got humidity up in the air, and you may even have clouds up in the air, but it's just not cold enough to make a raindrop, then what if we put crystals up in the sky? Now, crystals forms can be found. All of the salts that we talked about are in crystal form. So way, way back in old Western times, along with a snake oil salesman, there were people that would go around with cannons and salt and get the town to pay them to shoot the salt into the clouds. He'd pack up and go because that was going to seed the cloud to rain. Now, just as much as that person walked around and carried a cannon with it, there are now industries in which they fly airplanes up into the clouds and spray salt into the air to seed the cloud and maybe make it rain. So people make money on this. Again, they don't claim it actually works, but why would a farmer pay someone to throw salt up into a cloud? It actually is a whole lot cheaper to have the water fall down than to pay for the water from the city to put on their crops. And so, yes, it costs something, but if it does rain, then they can water their fields for a whole lot less money. Does it work? Do a lot of people do it? Well, there's an industry that is thriving. I don't know how many people do, but the theoretical idea is sound. the actuality, maybe a little bit shaky. Okay? Now, when we're describing things like rain, rain is classified as precipitation because it's any water falling from the sky, whether it is solid, liquid, or liquid. And so that's one thing that we look about when we talk about something called weather. And I think we don't quite understand exactly what the definition of weather is. And so here is the simple definition. Weather is a collection of data at a certain time. And so the weather is the temperature of the air, the humidity of the air, the pressure of the air, the cloudiness, and what kind of precipitation is given at any time. And so you have weather all throughout the day because you have different conditions all throughout the day itself. Now, most of the time when we say weather, you're probably thinking about climate. Climate is different. Climate is the average type of weather that you have in a certain area. And this is averaged over years. And so, the average weather in Puerto Rico when I lived in the Caribbean was this. Lows were 78, highs were 88, the humidity was 98%, and in the afternoon it rained somewhere on the base every day. Okay, that was most of the time. And then there was August when it got hot. Okay, and so on average it was this is what we found all the time. In your home, the average climate, the kinds of weathers that you would expect, you buy your clothes based upon this. How thick your coats are for the winter. You know, how many clothes, how many shorts you have because how long your summer is. How hot does it get? And so that's what you think about when we describe places with different climates. But weather is a single measurement or a collection of measurements at a single time. Now, to simplify this, we usually take weather reports or measurements of weather at certain times of the day, and they are reported to a national site that collects all this data set. The organization is called NOAA, and it is a site of information that every one of the meteorologists use this data site to predict the weather. What actually happens is there are some of the most complex computers in the world, the fastest computers in the world, are used to do weather predictions because there's so many data variables. It takes the largest computers to do this. The other components that these computers are used for is to do development of nuclear weapons and weather. Those are the two applications that they use for these fastest computer sets. Now, when your weather person decides what he or she is going to report, what really they're doing is they're taking the top 7 or 8 weather models that have been created. And what they'll do is they'll compare all of those 7 weather models. And if 6 of those weather models agree, then they are pretty confident to tell you that the weather is going to be like this in the next couple days. Although that 7th that calculated something different could be completely right, and the other 6 are wrong. And so, but there are different ways to set up how you use the data, and so there are major models that are out there that are calculated to and given out all across the country, and basically everybody uses the same data. It's how they interpret that. Meteorology is actually a study. It's a scientific study, and it involves a lot more math and computer programming to actually do that degree than you might expect. Unfortunately, we have people in the news department that would like, and sometimes you get a weather person who is very, very handsome or very, very beautiful to read the weather, but they're not actually the ones interpreting the data. The person like that is usually in the back, and she or he is probably not as photogenic as the ones they put in front of the camera. Okay? Weather is powered to simply do 2 things. It is to make the earth the same temperature all across the earth and to distribute the humidity evenly all across the earth. That is the reason why we have weather. That's the reason why we have all these changes. Now, will we ever make the Earth's temperature exactly the same all over the Earth at any one time? No, you can't. And the simple reason is this. Because we are round and we get energy from the sun, there will always be one face that is being warmed, that are facing the sun, and the other side is cooling because it is away from the sun. And so all the time, one half's getting hotter, one half's getting cooler. So we'll never get it even. But because we have atmosphere, the heat from the hot side tries to roam around to the cool side, and we get wind. Okay? And the hot air carries lots of water. When it gets cool, it falls out, and we get rain. And we have all the weather that we see is because the earth, the atmosphere is trying to distribute it evenly. All right, so weather starts with the sun. It's the sun that starts it all. And so the sun is shining all sorts of energies at us. Light energies, UV energies, also heat energies. The heat technically is called infrared energy. And so heat and infrared energy are the same thing. And it will warm up the water and the land. And so they get warmed up. And then the water and the land will give off infrared energy and warm up the atmosphere. And so some of the energy gets deflected by the clouds. Some energy gets deflected by the ice, and some energy doesn't actually get all the way down to the water or the land, although most of it does. Some of it gets absorbed in the UV range in the ozone layer. So a tiny bit of energy actually warms the atmosphere directly, but most of the energy actually hits the water and the land. And so insolation stands for incoming solar radiation, the types of energies that come from the sun. So insolation. Now, here is the ideas about this. So all of the energy that is coming from the sun is coming down. So 100% comes to us. Okay? Stop. We lose 30% completely by reflecting off the ice and the clouds. So we don't even absorb 30%. Okay? This 19% gets absorbed in the atmosphere, mainly the ozone. Little tiny fraction actually warms up the atmosphere. Most of the energy hits the land and the sea. Okay. All right. Let's say, and there's an example of this. Okay, so it is nice and sunny out there, right? And I've got a parking lot right here, right? And I could take you all out and have you come on this parking lot, stand on the grass, and I ask you to take off all of your shoes and socks. Okay? Then I go all the way down to the end of the parking lot. And I take a dollar bill out and I put it on the ground and I put a rock on top of the dollar bill. All right, it is 2:40 on a July afternoon. I say, anybody who wants to walk all the way down the blacktop of the parking lot can come and get the dollar. How many people would go and get the dollar in your bare feet? Okay, 1, 2, a couple. All right, by doing that, what are you risking? Burning your feet, right? Now, if I put a $20 bill, anybody else? Oh, see. But a $100 bill. No, you got to walk. Okay, you got to walk. No, you got to walk. Yeah, how fast do you walk? Okay, but you get what I'm saying, right? That asphalt is hot, right? What made that asphalt hot? What kind of radiation? That is a good answer. The type of radiation that hits it is light. Okay? The light hits the black asphalt because it absorbs all that light. All right. The asphalt has energy in it. Is the asphalt glowing? So it absorbs light, but it doesn't give off light, does it? It absorbs light, and the energy is changed into the area called infrared, which is heat. Okay? And so most of the Earth is warmed by the light energy. It absorbs it, and it gives it off as heat. And that heat is now radiating off of the land and the ocean. Now that heat coming off, which is 51% of all the energy that the sun gave us, 45% of it warms the atmosphere. So directly, the sun warmed the atmosphere only 19%, but 45% of the energy had to hit the land, be converted into heat, and that really the land and the water is making the air hot. 6 of it goes straight up and is lost immediately. Over time, we will lose the rest of the energy leaked out to space. Now, our atmosphere allows light to come through, but the atmosphere traps heat inside. It is just like a greenhouse. You can grow tropical flowers in the middle of winter if you're inside a greenhouse, because the greenhouse has glass that allows the light come down. It hits the soil gets warm, heat comes off, but the glass traps the heat inside. In actuality, in the middle of winter, you actually have to raise the windows to make sure it doesn't get too hot, because that greenhouse effect keeps all of that heat inside. The same way, the gases in our atmosphere will keep the heat inside, and there is a balance point between how much we heat and how much heat goes off. If we don't have enough atmosphere to hold in the heat, we would be colder overall. That's not necessarily good for us because things wouldn't grow so well. But if there is a change in the atmosphere that holds more heat in than what we're used to, then it will leak out slower, and overall, we may be a little bit warmer on average than before. This is the idea behind what was first, and I think incorrectly termed, global warming. Probably more descriptive is climate change, in that if we mess with the balance, things are going to get messed up. And it can get messed up in so many ways. Now, why is it bad to talk about global warming? Well, if it's global warming, then everything should get warmer. And if one example in one place on the earth gets colder, then someone says, it's not global warming, it's not all warming up. Okay. And some arguments have been made that way, that not every place on earth is getting warmer on average. Fine, I can't argue that. That's real data. But here is what happens. If you mess up the balance of energy coming in and coming out, you can change the climate, meaning this. Well, in the Midwest, we grow lots of food because there's lots of light and enough rain to grow food, right? But if you change the climate and it just doesn't rain there anymore as often as it once did, then you may not grow as much food. Well, if it doesn't rain as much there, it's going to rain somewhere. And it might make our cities a place where lots of rain comes down, which would be a great place to grow food, but we've got a city there. Okay, we as people, if we can't grow food here, and the area where there's land, and this place now would become a place that we could grow food, but we got a city, are we going to move the city over here and plant here? My grandpa owned this land. This is my land. I'm not selling this land. This is my land. Even though we know that it might be good for us to do something, we're stubborn. Stubborn enough to kill ourselves. Right? And so if we are doing things to change how we utilize the land, that could be a bad thing. Okay? And there is a debate about particularly the idea of global warming or climate change. There's a lot of scientific data out there, but there is also a lot of things posted on the internet. And since anything posted on the internet is absolutely true, then there is some people that are that don't believe in what the scientific data is saying. I don't know why that is, particularly. There is resistance to the idea that we might be contributing to the fact that the climate may be changing by how we're interacting with the earth. But I think it boils down to this, is that if we're doing what we're doing and we're making lots of money, don't make me change, because I might not make enough money. In a lot of senses, the status quo makes some people a lot of money. To have that change, some of those people may not make as much money. And so there's a lot of resistance to change. It would be just like, and it kind of correlated to, we are really based upon a petroleum standard for energy, oil. Okay? Not to say that's good nor bad, not to say that's going to ruin our climate or not, but here's the deal with that resource. It is finite. It will run out. Right now, we're not running out. But at some point in time, we will run out. You can't avoid that. If we base everything upon that and we run out and we have no alternative, this generation ain't going to suffer, but someone will down the line, because we aren't looking forward to providing opportunities for other generations, because we're a little bit greedy right now. And it doesn't have to be everybody greedy, but if we don't do anything about it, we may be contributing to those that are, because it's a little bit too hard to do. Okay? Or it might cost us a little bit more. And so nobody wants it to cost anymore. But these are problems that we have to consider. Okay, so the sun is heating the earth. Got that? And one side gets hot, one side gets cold. It gets more complicated than that. Just because the sun is shining on that side of the earth doesn't necessarily mean that it's all heated evenly. Okay? And it is because we are a sphere and the earth is curved, that affects things. So, an example, if I take a flashlight and I shine it directly down on a desktop, get a nice tight beam and it's really bright, right? Okay? But if I take that flashlight and I put it over to the side, then the light coming out doesn't change, right? But that beam gets smushed all across the table. Does that light that hits the table look as bright? Not at all. What you've done is you've taken the same amount of energy and concentrated it directly, and when it hits at an angle, I've spread out that same amount of energy over a large area. It is less bright in any one spot. Because of the curvature of the earth, the rays of the sun at the equator are directly on. It gets heated much, much more quickly because it's more intense. Where we live, it is spread out, so we don't get as much of the intensity as we would at the equator. So places on the earth are heated at different rates. Not only that, land heats fast, water heats slowly. So if I hit water or I hit land, there's differences. Now, land cools off fast and water cools off slowly. And so one can give off heat longer, the other one very quickly up and down. So where you hit, where it's on the earth, if it's curved, all of these mean that it gets heated differently. That means the airs are different temperatures. That means it tries to mix up and it creates more weather. Okay? The energy that is given from the sun 80% of it is moved around the Earth inside the atmosphere in the form of weather. The rest of it, about 20%, is moved around in ocean currents. And so the movement of all of that heat that is coming from the sun creates all of our weather. Why in the world do we have seasons? Okay, here's the deal. If the Earth were straight up and down as we were twisting, then we would absolutely have no summer, fall, winter, or spring. It would be the same temperature all year long. But because our Earth is tilted a little bit, okay, for here in June, up here in the northern hemisphere where we live, mainly is facing the sun. I get a lot of sun that is facing us, okay? We get hotter. In December, we're at an angle to the sun. We get less sun, and we get cooler. In spring and fall, we're a little bit more direct. The tilt is affecting us less, and so we're between the two extremes, and fall and spring feel about the same. And so this tilt tilts us towards or away from the sun at different times of the year. And it's totally opposite if you live in the southern hemisphere. I used to work with language and literature, and we would fly down to Santiago, Chile in summer, and people would spend 4 weeks studying 2 years of Spanish. Was it 2 years? Yeah, they could get 4 weeks and a full year of Spanish, and then we spent a week going around the country. But the problem is we left in the middle of summer, right? But we go over the equator and we land in the middle of winter. I tell people that, and they pack, and there were several times in which people would land and go, oh, I have to go buy clothes, because they brought shorts and all kinds of short sleeve shirts, and it is winter. They had to go buy a coat and pants and sweaters and everything because they didn't know after I told them. And so the tilt causes the seasons. Now here's the deal. If the tilt were further, okay, more tilt, that means the winters would be colder and the summers would be hotter, more extreme. If I had less tilt, I would have less of a season. So if we were straight up and down, that would be cool. Because whatever temperature you wanted to live at, you could find. Hot would be the equator. Moved a little bit north or south, you get a little bit cooler, a little bit cooler, a little bit cooler, and it would be that temperature all year round, the same temperature. You could find your temperature and be there. We don't have that, but many people do enjoy the changes of the season.